We are beginning our study of Chapter 5 today, the movement of ocean water, with Lesson 1. You'll notice there are 3 lessons in this unit, and as always, the songs are at the very beginning. So Lesson 5.1 is dealing with currents. We have 4 objectives today. You should be able to describe surface currents, list the 3 factors that control surface currents, and describe deep currents, and identify the 3 factors that form deep currents. So ocean water contains stream-like movements of water called ocean currents. And Thor Heyerdahl, who was a Norwegian explorer, proved his theory that ocean currents influenced human migration by using a raft that was powered only by the wind and by ocean currents. So this is how we know that the ocean has these stream-like movements to which can carry things. So you're going to come back later and watch a brain pop on ocean currents. So let's break it down. We have surface currents, and these are what they say they are. These are horizontal, stream-like movements of water that occur at or near the surface of the ocean. Okay, so at or near the surface currents. Surface currents are controlled by 3 factors: global winds, the Coriolis effect, and continental deflections. So global winds, these are the winds that blow across Earth's surface. They help create the surface currents in the ocean. And different winds cause currents to flow in different directions. You can think of it like if you have a pan of water and you blow onto that pan of water, the water is going to flow in the direction in which you blow on it. So it's the same way with the global winds. The Coriolis effect, this is the apparent curving of moving objects from a straight path due to Earth's rotation. So Earth's rotation has to do with the Coriolis effect. And then continental, that should say deflections, not defections. Deflections are when surface currents meet continents. They deflect, which means they change direction. Same thing if that same pan of water, if you put a rock in the middle of it, a big rock, and you blow, the current is going to flow in the direction you blow, but it's going to separate at the rock. It's going to deflect away. So same thing here. When the current hits land, it's going to deflect or change directions from that. So after you view the following 4 image slides that we're going to view together, you will be at the end of Lesson 5.1, and then you're going to watch the videos for Bill Nye Ocean Currents and Climates, which will be on the following slides another day. So this shows you the Brazil current. This would be continental deflection. Here's the continent of South America. This shows you Earth's surface currents, and the ones that you see in red are warm currents. The ones that you see in blue are cold currents. And you can tell that the equator, of course, is going to have the currents coming from it that are warm. And then the north and south poles are going to have the currents coming from them that, of course, are cold. And again, these are your surface currents. So let's dig into the polar regions just a little bit more and talk about the deep currents. These, of course, are the stream-like movements of ocean water that are located far below the surface. That's why they're called deep currents and not surface currents. If they're down deep, they're not going to be controlled by the wind because the wind doesn't get down that deep, just the wind on the surface. And they form in parts of the ocean where water density increases. So the density of the ocean is affected by two things, temperature and salinity. And I did not mean to do that, so here we go. All right, so A, this is representing the surface currents, and the red represents warm. So surface currents carry the warmer, less dense water from other ocean regions to the polar regions. And then here you can see it's changing. Warm water from surface currents replaces colder, denser water. Because it's denser, it's going to sink to the bottom of the ocean floor. And then you have deep currents that carry the colder, denser water along the ocean floor from polar regions to the other ocean regions. And again, water from deep currents is going to rise to replace water leaving surface currents. And this is just a constant cycle. It's kind of like the water cycle over and over and over again. Remember, just like with warm air rises, cold air sinks, same thing with water. Warm water rises, cold water sinks. Warm water rises, cold water sinks. So how do these deep currents form? So we said that, of course, there are differences in water density, and this causes variations in the movement of these deep currents. So one effect is the decreasing temperature. So in Earth's polar regions, cold air chills the water molecules at the ocean surface, which, as we know, causes those water molecules to slow down and to move closer together. This reaction causes the water's volume to decrease. Thus, the water becomes denser. The dense water sinks and eventually travels toward the equator as a deep current along the ocean floor. In this next step, we are increasing salinity through freezing. So if the ocean water freezes at the surface, ice will float on top of the water because ice is less dense than liquid water. The dissolved solids are squeezed out of the ice and enter the liquid water below the ice. This process increases the salinity of the water, so the salt content. As a result of the increased salinity, the water's density increases. And we're going to reverse this process. Another way that salinity increases is through evaporation of surface water, which removes water, but of course leaves the solids behind. This process is especially common in warm climates. Increasing salinity through freezing or evaporation causes water to become denser again, sink to the ocean floor, and therefore form deep currents. And then this is the Bill Nye that you'll watch later. Another Bill Nye. And then the next time we will talk about currents and climate in lesson 2.